let's continue. Where? I need to pause this. Well, you know the idea really well. So, tau d, when we solve this quadratic equation, so what is the b is minus tau I ideal, so minus b, tau I ideal, plus or minus square root of b squared, minus 4, the a is 1, the c is tau I ideal, tau d ideal. Divided by 2. So, how do I find if the plus or the minus is the correct one?
You plug it back in.
Those of you who have been in classes with me, I have emphasized this as a general concept many times. I have to choose between a plus and minus. What should I do to help me guide me if it's the plus or the minus?
Some sort of graph? Graph it?
I'm looking for one word, starts with an L. This is a general strategy. You have a wide range of situations you have to choose between plus minus. Limits. You look at limits where you know the answer. So, do I know the answer plus or minus for a particular limit? I think I may have done it though by the way. I may have done it correct, but I may have done it opposite from what I did in the notes. Let me see. But
it's actually the exact same equation, but it's for tau I instead of tau.
yeah, I wrote for tau I and not for tau d. But anyway, I'll translate to the tau I equation. But so which limit do I know? Which limit do I know, guys? Do I know a particular, if I have tau d equals something, for sure if tau d ideal is something, the tau d should be something. Come on, someone figure it out. Oh.
Tau d goes to 0.
Exactly. If tau d ideal is 0, if I have no derivative action, obviously I shouldn't have any derivative action in the commercial controller. Notice, by the way, if tau d equals 0, what do you have? Look at the top left equation on this board. If tau d equals 0, what do you get? PI, standard PI controller. So if tau d ideal is 0, I should get also tau d commercial 0. So if you put tau d ideal 0, it becomes square root of tau I ideal squared. The taus are positive. So what's that? Tau I ideal. So it should be the plus or the minus.
Well,
You get 0. Should be the minus. Right? Since for tau d ideal equals 0, tau I should be equal to 0. That means minus is correct sign. Now, unfortunately, I did it differently. I should look at my notes very sometime. So I get tau I ideal minus square root of tau I ideal squared So, over 2. So 8. Of course, tau I is tau ideal minus tau D. Obviously, we have calculated this, that's the simplest way to do it. But just to show you the equivalency with what you have in the notes, if you take this minus this ratio, this divided by 2, so making common denominator, you get 2 tau ideal. So this is tau ideal. Tau ideal minus tau ideal. I should have been just ID. Minus the square root over 2. And of course, this is the same as 2 over 2. Make common factor. What do I have? I have 2 tau I minus 1 tau I. Gives me tau I ideal. And then minus the square root becomes plus the square root of tau I ideal squared minus 4 tau I ideal tau D ideal over 2, which is Noether's equation. So that's the equation we have in the notes. Okay, in the notes I did the quadratic for tau I, so I solved for tau I. Here I did the quadratic for tau D and solved for tau D. Making, are we doing okay? No?
I don't understand why tau D ideal 0, but why is tau I 0? There's no tau I.
Oh, the ideal, oh! That's why. Okay. At least I look at your faces, guys. So that helps me pick up my mistakes. All right.
The tau ideal also be over 2?
Yeah. You're right. I didn't.
What did you just do?
It extends. This line extends. He's right. The line extends. I didn't draw it. Because everything is common denominator over 2. So that's the equation you have in the notes. If you do the quadratic solving for tau I, you get this result. So fairly straightforward, right? I have those two equations. I'm matching tau D ideal with this, and 1 over tau I ideal with this. This gives me two equations. Remember, tuning gives me the ideal. I'm implementing the conversion. So I'm implementing Kc tau I tau D, while I have available Kc ideal, tau I ideal, tau D ideal. So I'm solving these two equations for two unknowns. Andrea and Maggie. I'm solving these two equations for those two unknowns. And I can replace tau I plus tau D from here to rewrite the first equation like that. And then I will substitute either tau I or tau D here. If I substitute tau I get an equation for tau D. If I substitute tau D as I did in my notes, I get an equation for tau I. So you get two different quadratics. That's the quadratic I get for tau D. Solving the quadratic using the standard quadratic formula gives me this expression for tau D. I have plus minus. I have to figure out which is the correct, is it the plus or the minus. Whenever you have to choose between plus and minus, please remember it. you look at limiting cases where you know the answer. So as Alden said, we know the answer that if tau d idea is 0, tau d must be not tau 1. Obviously. Andrea? What did you lose? Come on, what did you lose?
How did you get that negative? I don't understand how you got that.
How did I get the negative?
You plugged
Because,
in 0.
okay, this is the expression. If tau d ideal is 0, this disappears. Square root of a positive square is the positive itself. So it becomes tau I ideal plus or minus tau I ideal over here. What's the correct answer? The correct answer is when tau d ideal is 0, tau d should be 0. Which gives me the 0? The minus. Here, for if tau d ideal is 0, then tau d becomes tau I ideal plus minus square root tau I ideal squared over 2 square, because this guy is 0. So far so good? Okay? So, but what is the square root of the square root of a number? It's the absolute value, but if the number is positive and all the taus are always positive, the absolute value of a positive number is the number itself. So that becomes tau I ideal plus or minus tau I ideal over 2. So, what should it be? Should be tau I ideal or should be 0 when I have tau d ideal 0? Should be 0. If tau d ideal is 0, the real tau d should be 0. If my tuning calls for just PI control, I should have just PI control. Okay? So what gives me 0? Minus gives 0. Okay? Give me 0 for minus.
Can you do that for the TI?
Yeah, for that. For tau I, you would argue again, since a regular PI controller, tau I ideal should equal tau I. Tau I should equal tau I. Okay, because a regular PI controller, same thing.
So,
Thank you.
so do we want tau d ideal to be 0, or do we just want tau d ideal and tau d to equal each other?
Yeah, how did you know?
Well,
Like, how did you know you want it to be 0?
because I have no derivative action. If my tuning is for no derivative action means tau d ideal equals 0. I get the tuning for the ideal case, right? If my ideal case has no derivative action, what is the controller if I put tau d equals 0? I get just a PI controller. Same, no derivative action, commercial and ideal case are the same, just PI. Kc times 1 over plus 1 over tau is.
So, for the equation, the notes in the equation, should it be minus tau I ideal minus?
No, because
y
the
is
notes in the
plus-
equation are for tau I is this equation.
Right.
In the notes. Notes equation has this, has the tau I expression. This is what tau I is, this is what tau d is. Tau d, tau I, different things.
Right, no, I'm saying, but you have
So-
minus here
Hmm?
and plus here.
Yes, this is with minus, this is with plus. That's correct. Minus, this is tau ideal minus tau d, this equation here.
Oh, I get it. Okay. No.
Okay? So when you have minus, minus, it makes it plus.
Minus and plus. And 2 minus 1 half.
Are you okay, Caitlin?
Sounds good.
Ashley, okay? Alright.
Wait, one more question. If
Okay.
TD is negative, then
They
TY.
can never be negative.
No,
The
I'm
taus
sorry.
are never negative.
No, the sign thing. If one's
Yeah, tau d
negative,
is with the minus, tau I is with the plus.
so if one's negative, the other one has to be the opposite?
Yeah.
Oh, alright.
Not because the relation minus uniform. And the last one is the Kc, and this relation between Kc ideal and Kc. So you can simply, I already found tau I and tau d. So having found tau I and tau d, you simply set Kc as you have Kc times tau I plus tau d over tau I equals Kc ideal. So the Kc that I implement is Kc ideal divided by that, which is the same as multiplying times tau I over tau I plus tau d. And this is my notes, corrected notes, because at one point I had it mistaken. I had it as right? Oh, yeah, here I have the conversion. Okay. No. All right. So that's the translation of the parameters. And how about tau f? So you have a commercial, you have your continuum. You get Kc tau I tau d ideal. You translate them to the actual Kc tau I tau d of form star 2. How do you tune the filter? That alpha parameter, that proportionality constant. Well, you have to look there is at your noise. Okay? And you have to consider what frequencies you need to keep. So look at your noise, see, it depends also if you have a digital signal, how often you sample, decide what's the frequency of your noise, and the frequency of your noise, when you look at real data, kind of guesstimate from that what's a reasonable period to use for your noise. 2 pi over tau is the frequency of your noise, so you want a breakpoint frequency that is to the left of the frequency of your noise. Okay, so that's how you would tune a commercial. Clear, everyone? All right. I have the manual of one commercial controller, and this is manufactured by Mod. And let me pull class notes. And look at it. And let's reason it out. That's almost this, doesn't do exactly this that I discussed, but that's something similar. As we will see, what it does is completely equivalent to what we discussed if the set point changes are piecewise constant, which is a common case. But if you make a ramp, it wouldn't be identical. But normally the ramps are approximately staircase. So let me put this. This is the picture itself. Yeah. So let's go to the class notes. And I'll have to be projecting on one side. There's not even any, okay, there's that projected. In the past I have used that project.